All right. So meet you again in this class on the financial data analytics. And for tonight class, we are going to learn about the financial data analytics using logistic regression. So I will gather both the binary logistic regression and multinomial logistic regression. So the learning objective is that you understand what is regression, what is logistic regression, what is linear regression versus logistic regression, what is binary logistic regression and multinomial logistic regression, and we will have some use case and demo. So in machine learning, we learn about supervised learning and unsupervised learning. Also reinforcement learning. In supervised learning, there are divided into two types of supervised learning. First is regression. Regression using let's say using the continuous data type, like what we did in the linear regression, that we are using the continuous dependent variable, weight, salaries, using continuous data. Return, and number two is classification in the supervised learning. So in classification, there may be two kind of classification. First one is between yes or no, or two classification, and then the other one is more than two classification. Many in the y dependent variable. The y dependent variable. Two classification or more than two. In regression analysis, we learn on the predictive modeling techniques that estimates the relationship between dependent variables as a target and independent variable as a predictor. But in logistic regression, in a binary logistic regression, it results into two categorical dependent variable, which is 0 or 1. This is on the binary logistic. 0 or 1, yes or no, true or false, high and low. Let's say the case of Nining in the bank. They want to develop a credit scoring using binary logistic regression. There is default, customer, and non-default. Okay, so this is 1, this is 0. Or there will be multinomial logistic regression. Multinomial. which having more than 2 categorical dependent variable. Maybe 5. 1, 2, 3, 4, 5. Let's say in Nining case on the credit scoring. The first one is collectibility 1. Collectibility 1, call 2, call 3, call 4, call 5. 1 is paying on time. 2, having delay until 30 1 until 30 days delay. Collectibility 3, 30 to 60 days delay payment. Collectibility 4, 60 to 90 days. Collectibility 5, 90 to 120 days. Yeah. So this is on the using multinomial. That y dependent variable cater 5 category. Call 1, call 2, call 3, 4, and 5. So when people apply for a credit, they may go to call 1, or call 2, or call 3. So the model predict that Sachin will go to collectibility 2. The model predict that Irwan will go to collectibility 4. It is there using multinomial logistic regression. So why not linear regression?
Jerry, sorry,
yes,
Pak.
Yes, Nining.
So for the multinomial, is it we can call like it's a clustering model because there are more than 2?
This is not a clustering model. This is
Regression.
probability of default.
Yeah, but it divided into 5 rather than a binary only 2, Pak.
Yes. So because the classification is more than 2, so which are you going into? Are you going to go to call 1, call 2, call 3? So the model predict you will go to call 5. The model predict you will go to call 5, therefore the bank reject your credit. Arasto?
Oh, okay, Pak. How about
Binary.
Ordinal logistic? There are 3 types, right?
Ordinal logistic. No. The topic for tonight is binary and multinomial. Ordinal is another topic.
Okay.
So we will cover only binary and multinomial. But since you are asking, no worries. Let's check it. Because I did not cater it in the slides, yeah. Ordinal, is it this the same as ordinal logistic regression? Oh, not ordinal logistic, ordinal regression. There is no there is ordinal logistic, ya. Okay, wait a second. Logistic is usually taken to mean binary and okay. Ordinal is general term for a model that could the y is continuous. That is ordinal. So ordinal logistic regression using continuous. Oh, can you give it a second? What is ordinal regression? Still sigmoid, but it is continuous. Okay, we will see whether we can cover it later, ya. Okay. Okay. So far so good. Any questions? Araso? Okay. Okay, so why not linear regression? Yeah. So in linear regression, the y can be unlimited. So we have a model like this. It may go up until this and going down like this, minus. Yeah. So we'll be going into minus and unlimited. Meanwhile, the value of y will be caps on 1. Upper caps will be 1 and under caps will be 0. So we cannot do with the linear regression because your objective is whether he is default or non-default, 1 or 0. We need to identify whether she got credit or the bank will reject, approve or reject. So binary logistic. Yeah. So we cannot do this with the linear regression. There will be 100, 300, unlimited on the caps. So that's why we need to have another type of model, which is that the model having caps on 1 and 0. Yeah. So that's why we come up with the logistic regression. Because logistic regression can develop the number of maximum of 1 and minimum of 0, which called the sigmoid curve. The curve is like the S. Yeah? The sigmoid curve. Maximum is 1 and minimum maximum until 0. So whether Nining will be granted credit 1 or Nining will get rejected 0. So that is what we want to know. We want to decide. So mostly risk management. So mostly risk management using logistic curve, yeah, to calculate the credit scoring. In this logistic regression curve, there is some jargon named threshold value. What is a threshold value? Threshold value is the value which determine whether the customer or the result is 1 or 0. If the Y volume is above 0.5, let's say 0.5, if you put the threshold value 0.5. If it is above, then it is 1. Or then it is considered approved. But if it is below 0.5, on the Y value, it is considered reject. Good or bad? You can put it differently. Whether 1 is bad, 0 is good. It's up to you. Depend on your Y variable and X variable. If you put 1 as good, you can do that. But if you want to put 1 as bad, you also can do that. Depend on your why. So the threshold will be determined by your judgment. What is your threshold value? Is it 0.5, 0.6, 0.7, 0.8, or 0.9? The higher the threshold value, the higher the lower the risk. The higher the threshold value, the lower the risk. If 1 is good, and 0 is bad. The lower the threshold value, the higher the risk. Because you will put people with the probability of default or probability of non-performing very high. Because they are having low score. So the threshold value depend on the business cycle. The business cycle. Business cycle. Set. This is the product cycle. Initialization. So the product just released. Usually the threshold value is very low. The threshold value low on the initialization. And then it is going to mature. The product will become mature. Sustain. Initialization, sustain, and then you are going to on the sustain. You want to increase the threshold value, and then when you want, there is the cycle of growth. You want to decrease the threshold value, and then when it is going to decline, you want to increase the threshold value. So it depends on the product cycle. What is the product cycle of a credit card? What is the current cycle of your product? Is it on the initialization? Then you need to lower the threshold. Is it on the sustain? You need to increase the threshold. And then you are going, is it on the growth? You may stay on the you keep the threshold, and when it is having maturity and or declining, then you want to decrease the threshold. So it depends on your judgment based on your business cycle. So what is logistic regression? Logistic regression is a method used to predict a dependent variable.
One question, why it is called logistic regression? I mean, what is the meaning of logistic here? Either it is looks like log or what? I mean, linear, and we understand that because linear regression, multiple we understand.
Okay.
Why we calling this one as a logistic?
Why you call it logistic regression? Because because this is I will come to that later, Satyen. Wait a second. Okay. Logistic regression is a method used to predict a dependent variable. You may have it on the categorical of 2 or more than 2. Yeah. Given a set of independent variable, where the dependent variable is categorical. Dependent variable can be binary, like 0 or 1, or multinomial, like A, B, or C, multinomial. The independent variable can be anything. Can be Likert, can be continuous, yeah. But before that, you must ensure that the data already normalized. This is critical. You need to normalize the data into the same range. Recall when you have the marketing class before, Irwan conduct standard scalar and Carmelita did standard scalar, remember. They calculate the standard deviation. They calculate the they calculate the mean of the data, and then they calculate the standard deviation of the unit towards the mean. Is it positive or negative? Yeah, towards the means. Yeah? So that is using standard scalar, or you can do it like Likert, 1 to 5, 1 to 10. Yeah? So the data is in the same range. Yeah? Something like that. Maybe like 1 to 5 like Likert, or 1 to 10. Or using how many percent towards the means like standard scalar. So that is the independent variable. So you need to ensure that your independent variable comply with the normalized situation. And then what is the equation that is representing regression model? So in linear regression, you have y equal to c plus beta x, isn't it? But in logistic regression, this is answering the question from Sachin. We come up with this log from y divided by 1 minus y is equal to constanta plus beta 1 x1 plus beta 2 x2 plus blah blah blah. This is what differentiate logistic regression and linear regression. Log. Yeah? And
this log is what? Logarithm or what?
Logarithm.
Okay.
Log. And it will resulting with the final model will be like this. Y equal to 1 plus 1 plus exponential in the power of minus c plus beta 1 x1 so this is the final model. Y equal to, so because we need to get the y score, isn't it, to determine whether it is 1 or 0. So y is equal to 1 divided by 1 plus exponential in the power of bracket of minus bracket c plus beta 1 x1 plus blah blah blah. Bracket 1, bracket 2 close. So this is the final model. So in this model, y is the probability of an event to happen which you are trying to predict. Y. Yeah. Y.
So means y is always in between 0 and less than 1.
Yes, indeed. Always between 0 and 1. So y is the probability of an event to happen, 1 or 0, which you are trying to predict. If it is 0.8, then it is closer to 1. If it is 0.2, it is closer to 0. And x1 and x2 are the independent variables which determine the occurrence of an event of y. So, like in the linear regression. Yeah? So it will not determine the y. It will determine the y, but in different form like this. C is the constanta, which will be the probability of an event happening when no other factors are considered. So the value of y will determine whether your position, whether you are here, 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 or here. And if it is above the threshold value, then it is going to 1. And it is below threshold value, going to 0. So far so good. Capish? If still any doubt, please ask.
But I have a question only that y will never touch 0 and y will never touch 1. That is what I understand from this graph. Or it is going to touch 1 because it looks like it is infinite. The graph is going infinite and never touch. It will go close to 1, but it's never going to touch 1. I mean, that is
yes,
how we define the probability.
Something like that. So basically, the caps will be 1.
Mm-hmm.
What we are going to calculate is the probability of an event to happen. Yeah, is it going to 1 or going to 0? In between, they will have 0.88, 0.99, yeah, but never attach 1, the final one. Yeah, 0.99999, something like that. Yeah, or minus 0.000001. So up until the end, never touch the 0 and never touch the 1. So there is a caps there. Yeah, because the log, yeah, when you want to identify the y, it becomes 1 divided by 1 plus exponential in the power of minus constanta and blah blah blah. Any other question?
Will there be a situation where the this graph will be parallel to the y-axis?
Parallel to what?
Y-axis.
Y-axis?
Yeah, means we are talking about this S curve, right? Which is like starting from the red dot to the blue dot.
So this is the independent score. So there will be 1,000 people apply for a credit. So what is your score? Is it 1 or 0? 1, you got approved. 0, you got reject. What is your score? 0 point. So there is 1,000 people here. And then everybody scatter. And then how do you differentiate people that get approved and people that get reject? Based on the threshold value. Below threshold value, you got rejected 30% of the population, or 45% of the population, or 60% of the population get rejected because their score is below the threshold value. Above threshold value, then you get approved. Araso, Bindu.
Yes.
Okay. Bindu, if parallel, it will become, if the x1 and x2 become constant. So if there is no variable, it will become the parallel to y.
If x1 and x2...
Yes, I mean, if there is no variable, yes, if it is constant, then the y is become parallel to, I mean, the value is become parallel to y-axis.
Yeah, if there is no x variable, then it is constant.
Yes.
Yeah, no meaning. Yeah, no meaning.
Yes, no meaning. Then,
no meaning. Yeah. So that's why the independent variable will determine whether you are going to get approved or get rejected. Depend on your, and then you have a coefficient for your x that will determine whether you will get approved or rejected. Araso? Any doubt? Okay, let's continue. So we can identify then that there is differences between linear regression and logistic regression. In linear regression, there will be continuous variables. But in logistic, there will be categorical variables. In linear regression, we solve regression problems. In logistic, we solve classification problems. Yes or no, approve or reject, call 1, call 2, call 3, or call 4, call 5. In regression, we solve how much salary he has, what is his weight going to be. And in linear regression, the line will be straight line, and logistic will be sigmoid curve. So this is the difference between linear and logistic regression. So example on logistic regression. This is hours. Yeah. So the graph shows the probability of passing the exam. Passing the exam. This is passing the exam versus the number of hours studying. The logistic regression result gives the following output. There will be intercept and x variable. This is the coefficient -4, and this is the coefficient of hours. P-value below 0.05. Okay. Okay. And then z value. I think the z supposedly t-stats above 1.96. Okay. So we have the model y equal to 1 per 1 plus exponential minus 4.07 plus 1.5 x1. Yeah. So this is the model. So when Sachin, will Sachin pass the exam depend on his hours. Okay, let's say Sachin has it in the 2 hours studying. So he will be 1 per 1 plus exponential in the power of minus 4 times 1.5 times 3. Times 2 kah? 2 hours ya. So he got 0.26 below 0.5. Then Sachin will not pass the test. And then Bendu 4 hours. 1 per 1 plus exponential in the power of minus with the open bracket minus 4 plus 1.5 times 4. Bendu got 0.87. So Bendu having probability of passing the exam bigger than Sachin, because the probability is passing the exam because it is above the threshold value. So far so good. Capish?
So, Pak, the logistic regression function is for predicting the probability.
Yes, predicting the probability of 1 or 0 for the binary.
Only that.
Only for the binary. Okay, so let's say the binary is passing or not pass, isn't it? Binary.
So logistic and binary regression are the same thing.
Come again, Carmel?
Logistic and binary regression are the same thing.
Logistic. Binary is for two options, 1 or 0. 1 is pass, 0 is not pass. Binary logistic. Binary meaning only binar. By.
Okay.
B is 2. B
Yeah.
And then the other option is multinomial. Let me.
How about we have many options, Pak?
Yeah, that's why I'm talking about here.
Pak Jerry?
Yep.
Sorry, Pak, before we move on, can I ask a question about the logistic regression, Pak?
Yep.
So in this case, the threshold value is 0.26, right, Pak?
Threshold value 0.5.
Oh, sorry, Pak, I misunderstood the first sentence. So it's 0.5, is it, Pak?
Yeah. No, depend on you.
Then
Threshold value depend on us.
Then how do we set, Pak?
How do we set the threshold value?
Yeah.
The product cycle, the business cycle. Recall? Okay.
Sorry, Pak, elaborate more, Pak.
I repeat again. So you are asking about the
how do we set the threshold value, Pak?
this one.
The
Threshold
exact
value.
number. Yeah.
Threshold value. Depend on the business cycle. When Nining firstly introduced the mortgage of what a bank, something like OCBC Bank mortgage, something like. When you introduce the product, yeah, if you put threshold value high, then you will not have any customer, isn't it? Because everybody got rejected. So you put lower threshold. Yeah, okay, you put 0.3, something like that. Because you are the initializing the product, you need to have a big portfolio. You want to gather all that. You want to have a lot of customer. So this one in the growing stage. And then after a year or two, your customer is there, and then you got a lot of non-performing loans. You want to maintain the portfolio and fix it. You want to maintain the customer and reduce the NPL. So you increase the threshold, let's say 0.5 until 0.6. You want to separate the good and bad, and then do some restructuring. And then your portfolio is good, it become better and better, and then you want to boost your performance, so you decrease the threshold again, 0.4, and then you got grow. This is harvest. So you go harvest there, 0.4, and then yeah, because you have selected a good segments. Okay, you identify a good segment, and then you push it there, and then reduce because you have select several segments on your target, you can put down the threshold into 0.4 or coming to 0.3, because you have set up a segment which is good, not having non-performing there. And then there comes the product become saturated and decline. When it is decline because of the competition, and then yeah, you may also increase the threshold to 0.5. So it depends on your business cycle, Giselle. I'm not saying the threshold is 0.5. No, depend on your business cycle. Araso, Giselle.
Okay, but then is there a structured way or approach to actually get the exact number, Pak? Or is this like the common practice to set the numbers?
Okay, so there will be more detail on that. So, of course, there is a way to calculate that, but that is more complicated. Yeah, so very complicated because we need to see the vintage analysis. You need to segmentize and then calculate the NPL. Yeah, so and then also on the government regulation that when you have NPL, there will be some penalty to you when you are NPL, and when you have collectibility 1, collectibility 2, and then collectibility 3, there will be what we call pencadangan aktiva produktif. So it will reduce your profit. So it is on the regulation. Yeah? So you also need to put the regulation into the equation. Yeah, something like that, Giselle. I give you the brief, the brief condition because it also relates with the regulation. Yeah. When you have more people having non-performing loan, it will reduce your profit because there will be penalty given by the central bank.
Reserve, Pak.
Not restruct. So pencadangan.
Reserve.
Pencadangan aktiva produktif.
We call it reserve, Pak.
Reserve. PPAP ya, pencadangan aktiva, PPAP.
Ya, PPAP.
Yes, pencadangan aktiva produktif. Okay, so this is answering the Giselle. Okay, now we continue into the multinomial. So what about the multinomial? In the multinomial, the y having more than 1, more than 2. 1, 2, 3, 4, 5. So how do we calculate? Is it going to 1 or 2 or 3 or 4 or 5? It depends on the y1. Y1 is equal to 1 per 1 plus exponential in the power of c plus beta 1 x1. x1 1. And y2 blah 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 x1 2. ny3 blah 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 x1 3. So in y4 blah 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 x1 4. y5 blah 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 x1 5. So the coefficient will be given into each of the categorical. This is categorical 1, categorical 2, categorical 3, categorical 4, categorical 5. There will be intercept and hours. So for every categorical, there will be intercept and hours. So the model will be different for 1, 2, 3, and 4, and 5. But with the same independent variable, but the coefficient will be different. The coefficient for each of the categorical will be different. So that is how we determine multinomial logistic regression. If y1 is the highest one above all y, then your customer will be collectibility 1. If y2 is the highest on top of all of y, then your customer will be collectibility 2, meaning the payment will be delayed 1 until 30 days. If the y3 is the highest among all of y, then your customer payment will be delayed 30 to 60 days, up until y5. That is on the multinomial logistic regression. Can you imagine the concept?
Pak Jerry,
Yes, Giselle.
sorry Pak, I have a dummy question Pak. What does exponential mean Pak in a formula? Then like when you actually calculate it with like a calculator or maybe like through Excel or things like that, do you just type exponential or how?
Okay. What is exponential? Okay. Exponential exponent. Okay, wait a second. Okay. Exponential. Okay. Okay. Exponential function is increasing at an exponential rate. Okay, I need to find something that is more simple, yeah. How do you exponential? Exponential. Okay, let me see image. Okay, this one. Okay, this is coming back to the senior high school class, ya.
Yeah, Pak.
Okay, no worries. Okay. 2 exponential 2 equal to 2 times 2. 2 exponential 3, 2 times 2 times 2. This is exponential. 2 exponential 4, 2 times 2 times 2 times 2. Got it, Giselle?
Oh, so Pak, but here the equation is 1 plus exponential something. It's supposed to be like something exponential something, right, Pak? Like 2 exponential 2. But in the equation is just 1 plus exponential. So what is the value that has the exponential of the following?
Good question. Wait a second. Okay. This one. Okay.
Oh,
1 plus 100 exponential minus x.
oh, okay, Pak. So in the equation, it means that it's actually 1 plus 100, then exponential something, is it, Pak?
Yep. This is the logistic, isn't it?
Okay.
The sigmoid, yeah? This is the sigmoid.
Yeah.
Because
so
this is using 10, because the final the cap is 10, so you put 10 here. But if your cap is 1, this is 1. Got it?
Sorry, Pak. In your slides, Pak, the example, just now the exam,
Yes.
about the exam, it's 1 divided by 1 plus exponential something, right, Pak?
Yes.
So in that case, the value that has
The option is 1 and
exponential
0. That is for the binary 1 and 0.
So it's 1 divided by 1 plus 1
Yes.
exponential something. Oh. Then if the value increases, for example, this one, it's 10 divided by 1 plus something. So shouldn't it be like 1 plus 10 exponential, Pak?
1 plus 10.
When shouldn't the upper and the lower value be the same? Or does it not matter?
Okay, wait a second. Okay, so meaning that it is not 100, yeah. We use, okay. I need 10 times 10, 100. So in our case, there is 1 plus exponential with the power of minus x. Using 1, not 100, 1, because we use 1.
So 1 times 1 is it?
Yes, 1 times 1.
Oh, okay. Got it, Pak.
Okay?
Thank you, Pak Jerry.
Okay, good. So very good question, Giselle. I just realized that. Okay. So when we have multinomial, yeah, 1 plus exponential in the power of minus the model. So every y value will be with the caps of 1 and the low cap is 0. Maximum number is 1. Y2 also like that. So we put in the multinomial, we put binary model of the binary model in each of the classification. So that is the way we conduct multinomial. So multinomial logistic regression is used to analyze relationship between non-metric dependent variable and metric of independent variable. Multinomial logistic compare multiple groups through a combination of binary logistic regression on each of the options in the group. The group comparison are equivalent to the comparison for a dummy coded dependent variable with the group with the highest numeric score used as the reference group. So there will be a reference group which means 0. Okay, let's see like this. Okay, there is 1, 2, 3, 4, 5. Let's say if we put 3 as reference, then the 3 will not be in the equation because there are simply 0. 3 is 0 as a reference group. So there will be 1, 2, 4, and 5. 3 will be separated as reference group, meaning it is 0. Yeah. So we will go there in the demo. So that is on the multinomial regression. Yeah, so this one is more into the theory. Yeah. Okay. Anybody still has a doubt in the concept? Please ask.
Jerry.
Yep. Nining.
So for linear regression, we can compute as a simple using Excel like we did last week, Pak. So for this one, is it can do also in the Excel, Pak?
Cannot. We can do that. Oh, you mean for the logistic regression model, kah? We cannot. With the data analytics, only cater in the towards the linear. But if you have another type of Excel. The Stata Excel, something like that. So let me open my Excel. I think I have it. Okay. I don't know whether I have logistic, yeah. There. But we need to put some add-ins, yeah. We need to put some add-ins there. Wait a second. Okay. This one. You see my Excel?
Yes, Pak.
There is add-ins here. Oh, this one. Multiple regression. Yeah, I don't see that data. View. Yeah. Also, Excel has difficulties, yeah, because it is limited on the raw data is limited maximum of 1000 and the column data maximum 11 row, 11 column. More than 11 column, then Excel cannot process, yeah. So we basically with the data analysis, there is no logistic regression, only linear regression. Yeah, only linear regression. But using the add-in statistic, what is it? Oh, this one. Using Stat Excel, I think we can. But there is no only principal component analysis PCA we have, canonical we have, discriminant factor analysis, multiple regression. No, okay. Also no logistic regression. Yeah. So we cannot do using the Excel for the logistic. Okay, Nining?
Ya, Pak.
Okay. Cool. Any other doubt? No? We go to demo. Okay. Gagal. Codes. Okay, this one. Simple binary. Simple binary logistic regression. Okay. Still reading. Where is? Okay, let me share it. Public. Okay. So let's do simple binary logistic regression using data credit scoring. Yeah. So let's see. Let's open the file. Let's create the file. Credit scoring. Yeah. So you can copy the file, yeah. Okay. So this one is dummy data, yeah. Actually, I have the real data but that is for the. Okay. So this one is. We have 1, 2, 3, 4, 5, 6 variables, and this is variable number 7 is approval. Approve 1 and 0. 1 approve, 0 reject. This is variable age edu. So this is the using standard scalar already using Likert data. So age 5 will be very old, 1 very young, education 5 very high education, 1 very low education. Job, 5 position very high, 1 very low. Experience, 5 highly experienced, 1 low experience. Salary, very high salary, 1 very low salary. So this is normalizing the data. So I put data normalization on Excel, yeah. So the data is already normalized. Debt to equity ratio, how many percent already used for the debt? 5 is very low, 1 is very high. Yeah. So you have to have consistency on 5. 5 will be the good side, 1 will be the bad side. Yeah. Approval is 1 and 0. 1 is approved, 0 is reject. 5, debt is low, 1 debt is high. Salary, 5 is high salary, 1 is low salary. So you need to be consistent. Good is 5, bad is 1. Approval, good is approved is 1, reject is 0. High education, low education. So you need to be consistent with that. So I save it as the CSV file. Yeah. Save as CSV file. Okay. So we have the CSV file in here, and then I already upload the data into the Kaggle, the credit scoring one. So in order to do this is for the binary, yeah. Input pandas, SPD as usual, import Seaborn as SNS, and then from sklearn matrix we import classification report. From sklearn matrix we import accuracy score. So okay, so let me inform you. So sklearn. Okay. So if you want to see the reference, you can go to the scikit-learn linear model logistic regression. So you can, this is all of, there are a lot of tons of reference here, yeah. So you can use that as usual, but I will explain it in more simple way to you. And then import train test split. So we learned this on the linear regression, and then on the sklearn linear model we import logistic regression. Okay, so we import all the function that we need to conduct the logistic regression. Okay, so let's run this, import the pandas, Seaborn, sklearn, and logistic regression. Okay, running. Wait a second. What took it so long? Session.
Pak Jerry?
Yes.
Can we already get the credit scoring data from your Kaggle?
So you can copy and edit already. So I share it already. You can copy and edit. Find the button of copy and edit. So you can also having the data with you. Can you open my Kaggle and can you see my Kaggle?
Yeah, but I haven't seen the
copy and edit.
Yeah, the simple binary logistic regression and also the credit scoring. I haven't found it in your Kaggle yet.
Okay, so refresh it because I already shared it public.
Okay.
What about the other? Have you seen my Kaggle?
I already seen, but dataset is private.
Oh yeah, private dataset.
Okay, let's see. Public already here. This is public already.
Yeah, the dataset is public, but the
oh, you can.
I mean the simple binary logistic regression is public, but the Excel is.
You don't have the data here?
Yeah, we don't have it.
Okay. You just create it.
I just created
Yes.
by our own.
Yes. Age,
Okay.
edu, and then what else? Edu, job, working of experience, salary, 1, 2, 3, 4, 5. What else? 1, 2, 3, 4, 5. Debt to equity ratio. Okay.
There, approval.
Debt. Okay, this is approval. And then you just put the run between 1 to 5. Okay, put it here. Put it here. And then approval run between 0 and 1. Then save as PPTs. As a CSV file. Credit scoring 2. Yes. Yeah. Okay. Easy ya?
Yeah.
Okay. Okay.
Thank you, Pak.
All right. Save. Yes. Okay. Cool. And then you put it on the add data, and then yeah, and then you read it. So so here I already read the data: ages, edu, job, experience, salary, debt to equity ratios, approval. So this is the data. So I want to separate between X and Y. Yeah. So I think okay, this is another way to separate the data. Using iLog. In iLog, we have the data frame here. X is data frame of iLog, square bracket, colon, comma, colon, -1. This means all the data minus the last one in the right. Minus last one on the last one column in the right, meaning age, edu until debt to equity ratio. Exclude approval. That is X. Y is all data frame. Yeah. All data frame, colon, comma, -1. Only the one on the right. Yeah. iLog. So let's print the data. Print X hat and Y hat. So this is X will be ages, edu, job, experience, salary until debt to equity ratio on the head of 5. Yeah. And then print Y hat, yeah, using the approval. Okay, so we have X and Y. So far so good? Everybody still follow? Any error?
Sorry.
Yes, any error? Irwan?
Can you explain again the iLog, the X for the X one?
Okay, wait a second. I put it here. Okay, wait a second. Okay, this one. Okay, data frame. Okay. So the rule is data frame.ilog, or you can put df.ilog, depend on the name of the data. Back and then square bracket, colon, comma, start column, colon, end column. Okay. And then if you colon, comma, and then you put none in here, meaning all column. And then colon, and column is -1. So -1 minus the last one.
Last.
Yes.
Oh yeah.
And then if you use the colon, comma, -1, yeah. So you the start colon is the last one. -1. Last one, yeah.
Oh.
The start colon is the last one. So there is no end because the start colon is the last one. Araso, Irwan?
Yes, sure.
Okay, good.
Thank you.
All right. So this is the rule on the ilog. Yeah. So ilog is in the pandas, yeah. In pandas. We learn supposedly in pandas. Okay, cool. Everybody got until here? Any error?
Pak Jerry,
Yes, Nining.
why my Kaggle doesn't show like that, Pak, for the print? Is it because of the limited something like Giselle ever had?
Okay, can you share your screen?
This one, Pak.
You are not using your
But it's already
your Excel. Oh, this is using your data. Or you just create your data?
Yes, I create my own data,
Okay.
and already save it under the CSV comma unlimited. But the result is
Nah,
like
yeah,
this.
because you put colon with the dot and comma.
No, actually the actual is not like that, Pak. Just like this.
Okay, because you are using the English format, yeah, dot and comma. That is on the region,
Oh,
Okay, that is in the region. So you copy again your file, and then copy paste to another file, and then you text to column using
okay.
text to column using dot and comma, and then you save as again. Wait a second, because you use dot and comma, yeah. CSV file using dot and comma. Okay. So you need to text to column again, change to comma. Can you change to comma from dot and column? So you know your problem, yeah? So you need to change it to comma.
Yeah, I will try.
Yeah? You need to change it to comma. Okay, wait a second. If you want to change it in Python, changing the delimiter. Okay, you can change the delimiter in Python, something like this.
Oh.
Yeah. Google.
But instead of CSV, Pak, can I just like using Excel form? I mean the.
No worries. You can change it from changing the delimiter.
Okay.
No. Wait a second. Okay. So you choose changing delimiters, read file and changing the delimiters. No. Okay, wait a second. Oh, not this one. Okay, so okay. Something like this, yeah. Read CSV file, and then you have to put delimiter change there. So I will come to that later, yeah.
Okay, Pak.
Okay, Nining. And then after you have this, okay, and then okay, so let's do this later, and then let's which one? This one. Okay. All right. Okay, this one. Let's import the statistical model first, yeah. So let's find the model first. Okay, run the import statistical model as stats model SSM. And
Pak, I think you haven't share your screen, Pak.
oh, okay. Oh, yeah. Okay, I forgot. Wait a second. All right. Okay. All right. Share my screen. This one. Okay. See my screen now?
Yeah.
Okay. So go to the import statistical models .api SSM. So let's run this code. Yeah, forget about the above, yeah. Start from this one. So I give Nining another version on how to create the data. So we can also do like using data frame.drop. Yeah. So X will be data frame dot drop approval. So we have approval here. So we want to drop the approval. Df dot drop, comma axis is 1, meaning it is the independent variable. And then X hat. So we can drop the approval. So we have the head like this. So this is another way on creating the table, yeah. Drop on the Y variable. And then on the Y variable, we can use data frame of approval only. See? So do not need iLog, but you can use data frame of approval. We can have the data. Okay, after we have the X and Y, let's conduct data training and testing. X train, Y train, X test, and Y test. So it is for the train test split for X and Y with the testing size 20%, training size 80%. Okay. And then for the X train, as in the linear regression, we need to put the constanta there. So statistical model dot add constanta towards the X train. What is the data name? We name it X train underscore SM.
Jerry,
Yes.
what is the purpose of the testing, ya Pak? I mean, should we always do that if we make the regression?
We do that to identify the accuracy of the model. So
Oh.
we model it with the training data, and then we calculate the accuracy towards the testing data.
Always do 20%?
You can do 40%, depend on you. You can change the testing size to 0.4 if you want to do it 40%.
Every time we make the regression, we should do this.
No,
Or we can
if you want to check the accuracy, you do that. You do this. But if you do not need to do the accuracy checking, you can do all of them. Do not need to split the data.
Okay.
Depend on your objectives. Do you need to calculate the accuracy or not? If you want to calculate the accuracy, do the train test split.
But will it change the data?
No, the data is the same, but
It will the same regression.
no, different result, because the data for you, if you all use all the data, there will be 100 data you put the model. But if you conduct training and testing model, training and testing split, you will develop the model using 80% of the data, so the result will be different.
Oh, I see.
Yeah.
But we can do both. It's up to us, right?
Yes, up to you, Carmelita.
Okay, thank you.
Okay. So after we conduct the X train using add constanta, the data will be like this: constanta, age, edu, job, experience, salary, debt to equity ratio. Okay. And then here comes the logit model. So the logistic model is sm.logic towards y train and x train underscore sm, because we use the data which already has constanta in there. We name it logistic model, logit model. Okay. And then the result will be logit mode dot fit. Yeah. It will be logit result. Okay. Okay. Successfully. And then let's print the logit result summary. Ah, there you are, using binary. So which one has p-value? Okay, this one has the coefficient here, standard error, z, p-value. Wait a second, why p above z? Not p-value. Last week on the linear regression we have p-value, isn't it? Or different kah? Last week on the simple linear regression, do we have the same model? Supposedly p-value only, not p above than more than z. Oh, same ya, p-value kah? Yeah. Still p-value, the same kah with p-value. But why it is p bigger than t? Oh, maybe the same meaning kah? Okay, so this is p-value. We see that there is none of them significant because we conduct it with the dummy variable data, yeah? Dummy data. No worries, none of them significant. But from here, we can develop the model, which is where's my pen? Okay. Y equal to 1 per 1 plus exponential on the power of minus 2.6 times 0.1 times h minus, okay, let me open it another one lah. Enter. Okay. Y equal to 1 per 1 plus exponential minus 2.6 times 0.116 times h minus 0.13 times edu plus 0.24 times job plus 0.09 times experience plus 0.23 times salary plus 0.25 times debt to equity ratio. So this is the model of Y. Okay, up until now. Capish?
If we don't do the testing, can we also make the regression resolvable
Yes, like this.
like that?
Yes, of course. Like this. Using the all data, yeah?
Yeah. Can you give the example, Pak?
Using the same data. Oh, of course. Just later, yeah? After this, yeah?
Oh yeah. No worries. Okay, thank you, Pak.
Any question until now? On the Y model? So far so good? Capish? Araso?
So in here in the logistic, we didn't see the R square.
R square? Let's see. We have R square 0.064. But using pseudo R square. Another type of R square called pseudo.
But the interpretation same, like
Yeah, the same. The same.
Because it's so small, Pak.
Yeah, because
like,
there is none of them significant, isn't it?
Oh.
Araso, because the data is dummy, yeah. Yeah, the data is dummy, and there is none of them is significant. That's why the R square is very low, 6%. If the p-value below 0.05, so like in what happened last week, yeah, no, this one kah? Not this one kah? Where is it? This one, yeah. R square is 93%, isn't it? Because this is significant. Okay. So this one is not significant. Very high.
So the equation for this one, is there any equation, Pak, still?
Yes, still.
Like Y?
Yes, still. No worries. There is still.
Oh.
Yep. Or or you want to do only with the significant one. Because when you have someone apply for a credit, the data is there, isn't it? So this is all the data, isn't it? So that's why usually the bank, there is the option is like this, using all data or using the significant only data. And if you want to use the one that is significant only, you drop data, this is not significant. Oh, edu not significant. Okay, you drop. You conduct the logistic regression again using the significant only. Araso, ini.
Okay, Pak.
Okay. Any other questions? No question? Good. Okay, let's continue. So we have the model. We understand the model how the model looks like. So we want to use that model. We want to use this model. Yeah. To predict. Yeah, to predict. So we want to develop the model first. Okay, this is the logistic result. Yeah. What is the model looks like? The model looks like this, but in the black box model. The model in the black box, logistic regression model. Okay, the model is inside there. This one, the model. The model fit on the X train and Y train. And then we want to predict the accuracy on the testing data. So we want to check the prediction probability on the X test. Okay. So this is the result on the data testing. So the data testing will be like this. 0.613 on the X test, yeah, on the X test, and Y test. The Y test will be 0.38, and then 0.52, 0.37, yeah, 0.89, 0.35. What is the prediction? Reject, approve, above 50, yeah. This one is below 50, 38, 0. Above 50, 52, approve. Below 50, 0. Above, below 50, 0, 0. Yeah. So this is the prediction on the X test using the model that is generated using the X train and Y train. And then what is the classification? And this is the classification report, yeah. And then this is the accuracy report. Only 41% accurate on the Y test. 41% accurate. The model only, the model accuracy is only 41% because we have a data dummy, and then there is none of the variable is significant. Yeah. R square is very low. The accuracy also very low, 41% only. Yeah. So the model, the data testing saying that they are approved, but the model saying that they are reject. Accuracy only 41%, that the data is approved and the model, the prediction is approved. Only 41% accurate. that is approved in data but also predict approve, or it is reject, data reject, and the prediction is also reject. Only 41%. Okay, the accuracy. Yep. So this is on the binary logistic regression. Any question?
What should be the range of the accuracy of a model? It should be above 90% or above 50%, and an acceptable range.
Yeah, the high, the more the better, yeah.
Oh, okay.
So depend on the topics. If you are talking about finance, above 0.8, or if you are talking about risk management on the credit risk, it is 0.7, above 0.7 is okay. So it is high standard, ya Bendo, ya. High standard, above 0.7. Then you got, if the score of the customer is above 0.7, then you approve. So it depends also in the business cycle. Come to Giselle question again. Yeah. So
not such thumb rule. I mean, let's say for a banking sector, let's say it is a credit analysis or something, it should be like a model above 80, 0.8 is an acceptable model.
So this is telling how robust your model is. If it is 80, if your accuracy is 80%, the model is robust. You can use it. But if the model below 50, you cannot use it. Useless. What for you use the model? Only 40% accuracy. No meaning. No meaning. If you achieve 80%, 90%, you can use the model. It can predict 90% accuracy with 90% accuracy. So you have the pride of selling your model. This is actually.
We are starting a startup. Let's say. Definitely for a startup business, the models definitely there will be like multiple models. Like we will be making, scaling. Then we will be getting some improvement and all those stuff, right?
Yeah.
That kind of sense also, it is like the higher the better, right?
Yeah, if you can have 100% accuracy, very expensive, yeah. You will pay you will pay a ton of money. People will pay you ton of money if you can make a 100% accuracy model.
Yeah.
So this is the pride of a consultant, yeah. Me as a consultant, I can only sell my model if I achieve more than 80%. Then I can sell it. But below 80%, people will laugh at me. Can you imagine that, Bendo? Okay? Any questions?
Jerry?
Yep, meaning.
So in this case, like we cannot determine the threshold value, right? Because the prediction is so low.
The threshold value is 50% in here. You see? Below 50, reject. Above 50, approve. Something like that. Capish? This is the Y result, yeah? Okay. This is binary. Okay, just now Carmelita asked, what about if we do not put X-train and X-test, yeah, Carmel?
Yes, Pak.
So you do not need to do the testing splitting. Just use the X and Y. Yeah. So you can create you can do like this. XSM X sm equal to sm dot add underscore constant dot x. Yeah, so you create xxm, and then you just the same, you can create xsm equal to that, and then in here you can do the same, but you use only y and xxm like that. Capish? Kamel?
Iya, Pak. Okay.
Ya, gampang kan?
Sorry.
Yes.
Aku repeat again. If the testing 20%, it means only 80% data used, ya.
So the training data that going into the modeling only 80% of the data. So the model, the function select random sampling data, 80% data, random sampling. 20% will be for the testing.
Okay, thank you, Bapak.
Good. Okay, this one is the binary. What about the multinomial? Multinomial. Actually, just the same. You just change the data, because this is the logistic regression. They are the multi-class is using auto here. If you have the data of 3, classification of 3, there will be 3 model. Okay, let's do it. Okay, let me create the data first. Excel. Okay. Okay, this one is run between 1 and 5. Isn't it so? Okay. So there is 5 data. Collectibility 1, 2, 3, 4, and 5. Okay. Save as. Credit scoring 5. Now, sip. Okay. Okay. All right. So let's create another model. New nodes. Oh. Okay, wait a second. Where is the last one? Binary Logistic Regression. Okay, new nodes. Let's do it simple. Multinomial logistic regression. Okay, and then add data, upload, browse file, credit scoring number 5. This one. Okay, credit scoring 5. Create data. All right, there you are. Right, in this one. Okay, let's import the data. Codes. quotes. Okay, changing the data, copy. All right, and then quotes. I want to use, oh, this one is okay. Use the this one is better off. This one is missing. Copy the statistical model. Okay, and then code again for the using the X. So, what is separate the data between X and Y, and then select the Y, and then splitting the data again, no worries, and then add some constanta on the X, and then develop the logit model using the training data, and then see the logistic result, the statistical result, and then print the result. After you print the data, so you want to see the, you want to create the model through the black box model, but you understand how to develop it using the result of the logistic regression, and then you want to check the testing data on the result, and then you predict the result on the testing data, and then you see on the matrix of classification, and then you want to see the accuracy of the model. This is what make the model expensive. You know you have the accuracy there. Okay, let's run all.
Pak Jerry,
Giselle?
is there any way that we can increase the accuracy of the model, Pak?
Of course, you drop the variable which is not significant.
Okay.
So we have the approval rate is 1, 2, 3. Okay, approval rate. So on the NPL, supposedly this is NPL. The non-performing loan is 1, 2, 3, 4, 5. Yeah. So this is only the head. The head is 1, 3, 3, 4, 5. 2 is on the below one. Okay, and then you see the X here, and then you see the Y, and then you split the data, and then you create the constanta on the X data, and then wait a second. Logic model SM logit Y train X train underscore SM Y train. Okay. value error, and doc must be in the unit interval. What do you mean? Value error and doc. Oh, okay. And doc. No. Okay. What is the? It is telling and doc must be in the unit interval. Okay. Dependent variable is in the unit interval. If you want this value in another interval. Logic requires that the dependent variable y is in the unit interval. If you want logistic regression with value, okay. And that must be in the unit interval. Okay. Okay, so let's see another sample. Okay. Binary simple. This one is simple ya. Multilinear. This one kah? No. Supposedly the iris data. Iris binary. Have you name it here? Simple multinomial logistic regression. Simple multinomial logistic regression, this one. Okay. The iris data. This one. Oh, this is not the iris. Where is the iris data? Okay, for a second. With the multinomial. So this one already. Oh, okay. I see. Okay. Logit mode. Okay. Okay, this one is to see the printing ya. Okay, let's skip this first. And then I will come to that later. So let's model the logistic regression first. So we want to develop the model using to find out the model in the black box. Yeah. So model equal to logistic regression with the multi-class of auto, meaning he will get the result of this in a black box manner, yeah? Because already auto. So he will identify y1, y2, y3, y4, y5. Yeah. And then let's predict the model. So for the individual number 1, his y score for the y1 is 0.09, y2 0.12, y3 0.11, y4 0.39, y5 0.27. Which collectability does he belongs to? Which one? Y1, Y2, Y3, Y4, or Y5? For client number 1 on the X test. Do you see what I mean? Which Y does he belongs to? Client number 1, Y1, Y2, Y3, Y4, Y5. Which one does he belongs to? Y1, Y2, Y3, or Y5? Just guess. Y4, yes, indeed, Sachin. Because the highest score is Y4. Isn't it? So, he belongs to Y4 because the Y is the highest one. On the client number 2, he belongs to Y number Y3. Client number 3 belong to Y3. Yes, that's it. And then let's predict Y4, Y3, Y3, Y1, 1, 1. So 1 will be collectibility number 1, meaning no delay in payment. 3, if 2, 1 until 30-day delay in payment. 3, 30 until 60 days delay. 4, 60 until 90 days delay. 5, 90 until 120 days delay. So we can predict someone will be paying late on the credit installment. Okay, so let's see classification and then the accuracy. What is the accuracy model? Oh, 0. Not accurate at all. Yeah. Because the data is dummy. Yeah. So this is the data is dummy, none of them significance, but I cannot put the significance because there is problem here. I need to find why this is having problem. Yeah, on the model. Yeah, using the stata model on the I will check it later. Yeah, but the concept most likely the same. Yeah, so maybe I need to improve a little bit on the model. Okay, the concept is just the same. But using this one, it runs and we see the result and we see the accuracy of the model. Yeah. So we need to drop variable which is not significant towards Y2 until Y5. If it is significant to Y1, not significant onto Y5, so we can still use the model. But if it is not significant at all to all of the 5, we just drop it. So far, any questions?
Pak Jerry.
Yes, Indah.
Yeah,
My apologies if I'm too slow following your class because I still got error in the fourth step, I think.
Okay.
When trying to show
Okay, show
the...
me.
Okay, wait.
Yep. You have the same problem with
With
naming,
naming.
yes, using, because the
Yeah.
region is, okay, we need to come with the delimiter, yeah. So we need to, with the delimiter, you read the data with the, using the colon, yeah.
Okay, so it will keep showing error like this.
Yeah, because the data,
When I
they
give
cannot
to-
read the data because the data is not separated, yeah.
I
The data
see.
still in the text, still there in one row. Sorry, in one column. You can go above. The data is still in one column, not separated into 5 columns, because
Yes,
the delimiter is not comma. So we need to change the delimiter. The default of read CSV is using delimiter comma.
Okay.
So we need to
Okay, Pak.
put some codes to change the delimiter into colon.
Oh,
Okay,
okay.
let me check first.
We'll change it, then try it later.
Yeah,
Thank you,
yeah,
Pak.
okay. So any other questions? Read.
Pak
Yes,
Jerry,
Giselle.
is there any website that has all this formula and the explanation behind the formulas?
V3 school.
Because sometimes I miss your
This
explanation
one.
and I'm quite confused about the formula.
W3 school.
Oh, okay. So we can just type the
V3 school, yes.
formula that we want to know, is it?
You can learn Python. But this is basically for the fundamentals. For the data science, does it giving the data science on the model? Yeah, for the this one. Yeah, this one is linear regression. Where is the logistic? Oh, he does not give the machine learning on logistic, yeah. Only the linear regression. Okay. Something like that, yeah. Polynomial on logistic. Okay, this is training and testing. Also, they give training and testing. Yeah. And then for the logistic doesn't have on the logistic. So still limited until linear regression, yeah. Multiple linear regression. Not yet to logistic and advanced topic, yeah.
Oh, okay.
Yeah,
Pak.
but you can learn. This is the reference, yeah. The W3 school, yeah.
Okay. Thank you, Pak Jerry.
Okay. So let me check in the read CSV using delimiter colon. Okay. Semicolon, ya. Semicolon. Oh, okay. Problem solve. So we need to check the reference, ya. Okay. So CSV path. Okay, wait a second. Oh, separator. Using comma separator colon. Okay. Okay, you put this one ini. Indah. Add separator equal to semicolon on the this one.
Okay.
So okay, read data and comma this one. Separator is semicolon. Try it.
Separator is semicolon. Okay.
Running. Success. Nining, Indah. What is the result?
Separator is semicolon. Invalid syntax.
Invalid.
Oh wait, I forgot to put the apostrophe, I think.
Can you share your screen?
Yeah, Pak.
Can you share your screen? Can I see it?
Yeah, it's running.
Okay, can I see it?
Yeah,
Just want to make sure.
this way. Here.
Yay! Good job.
Yeah. 감사합니다.
감사합니다. Okay. Nining, your problem solved ya? Okay.
Yes, Pak.
Okay, good. Okay. Any questions?
But Jerry, but when I try to call the logistic regression multi-class auto, it's still error.
Multi-class auto, because you need to develop the X-train SM first, Y-train. You need. Have you run the X-train? SM?
Yeah, already.
Okay,
X-train, Y-train.
Can you share your screen again?
Yep. Yep. Sweet.
Mimai desu ka?
Yeah.
Okay. Yeah, create the
So
X-train
I
first.
already run this.
No, X-train. Where is your X-train? So your X-train is still in one column, is it? Look at above. Yeah, this is still one column.
So I also have to put the separator in here.
Yeah, run again. You haven't run it yet. Yeah, run it. Okay, done. And then you can run it. No. Before that, the X-train first. Yeah, run first. Okay, and then below. Now, okay, and then you run it again.
Oh, no.
Oh, the X is using big X.
No. I have it already in
Yeah,
here.
that is big X, not low X. Lower the X.
Yeah, I think I can delete it
No.
because I have already in here.
Oh, double counting kah?
Yeah.
Okay, delete it.
No.
Yeah. And then run
Yeah.
the model predict. No, X test. You use X with the big X, not the low X. Sorry, X test using X low kah? Oh yeah, low is low ya.
Yeah, X low.
X low.
But I think I missed some steps before predict.
Oh, you haven't write the text before predict kah?
Yeah. I think I will complete
Okay,
it
complete
soon.
first. Okay, because it is not defined yet the X test.
Yeah.
Okay.
Got it.
Okay.
Yeah.
Nice.
Arigato.
Bye. Okay, so any questions? Any questions on the logistic regression? So far so good? Capish?